Hey guys, welcome back. In this video, we'll be covering about exceptions. Yeah, let's get started. So we have seen before that sometimes we cannot always trust the values that gets transferred between functions or user inputs because for example, you're expecting an integer, but sometimes people might enter, say, a float number and so forth. So there's a lot of things that could cause an error, and often when an error happens, the program crashes without doing any further instructions, and that's not the behavior that you want. So even if you encounter an error, you will still would like your program to continue to run with the remaining processes by handling what we call an exception, right? So here's an example of print reciprocal. So basically what it does is find the reciprocal of a number that's given. So obviously if you give, say, an integer value or a float value, you would expect this to work correctly. But for example, a person who provide an input is being a little bit typical. Say it gives a string of the value, or string 4 in this particular example, then obviously this is going to fail and give us an error, right? So let's give that a go. So here's the reciprocal function as we've seen in the slides, and we're going to call reciprocal with 4 and then string 4. So if we run this, then here, as we expect, reciprocal of 4 is 1 divided by 4.5, so this is fine, our first one. However, if you pass in a string, this is where an error happens. So on top of the operand for float and string, basically we can't divide a float number by a string, it doesn't make sense. So more often than not, things go wrong. So you probably have experienced throughout the labs that when you test things, we see some sort of error that occurs and that just crashes the program. So exceptions are unexpected happenings, basically. So program tries to read from a file that doesn't exist. A network connection breaks, that happens. User interrupts with the control C during the program. A program runs out of memory, that also happens. Divide by 0 and so forth. There's a lot of different types of exceptions that can cause an interruption to your program. So an essential idea is that we know only that these things might happen, but not when they will happen. So we can expect these type of errors can happen sometime during when we execute our code, but we don't really know exactly when it's going to happen. So all we can do is put some safeguard, some checks to ensure that we can capture these scenarios. So there are ways to capture these scenarios. For example, using if conditions to make sure that if conditions and some built-in functions or methods to capture that only expected inputs are given, but those can be quite tedious and a long extension to your current program. Okay, so that's the old style. Basically, what old style did was, well, even if we go even older, then they didn't even have a built-in way of handling exceptions. So you have to do manual capture of exceptions. And functions therefore used special return values to indicate an error. So if something happened, you want to print some specific error related to that. And those are not really efficient way of handling exceptions in nowadays programming paradigm. So we probably don't want to put a lot of safe code to capture those exceptions. Rather, we're going to use Python's exception handler. Okay, so how do we handle exceptions? It's very straightforward. What we want to do is specify, okay, try this piece of code, and if any exceptions happen, then we're going to capture it and do something about it. So it's kind of like an if condition. If something bad happens, then we'll do something about it. Similar idea. So in exception, we call it a try and except blocks. So we have the try block, and this is the block of code that you put in that where you suspect something bad can happen. So in this example here, division can often cause a lot of error if the variable input is not valid. So this is where we will try to capture an error, and if something does go wrong, what we'll do is print this does not have a reciprocal. Okay, so here, so let's add print reciprocal of 0. Okay, and here we will expect that it's going to crash, and where it crashes is here, where this is error, and so this one doesn't even get called. Okay, so this is a bad behavior out of this one. So we have our next set of 1, so we call it a reciprocal 2. Let's run the same code again, and what do you think is going to happen? You can pause the video here and try to think about what might happen. All right, let's run this. And here what we expect is that it runs as normal, so you don't see this long error message popping out saying that you can't do this or you can't do that. But rather what we did was, okay, something bad happened here. So instead of displaying that long error message, what we're going to do is handle it through this exception block. Okay, so this exception block will capture all the errors that happens inside this try block. So if I take this division outside the try block, then I'm going to see the error messages again. So you can try this yourself. So what happened was my division reciprocal 1 divided by 3 is fine. So it will print out my normal message. But if this fails, for example, string 4 or 0, then I'm going to say that, okay, this one does not have a reciprocal. Okay, so this is what we expected from here. Okay. However, if you do write up code like this and submit into a quiz server, then Pylint will complain about this. Okay, what it really wants is, rather than capturing all generic exceptions, it wants you to capture all the specific exceptions that are happening in your code. Okay, so exceptions allows us to separate normal from exceptional code. So when something exceptional happens, then that's how you want to handle it. So if an exception arises, normal processing stops. That's why we did not see this print happens for this couple of 2 inputs. And what they're going to do is put you straight into an exception case. So if an exception is raised, then Python jumps to the exception handler in the except block and execute the code there to catch the exception. So you move straight into the except block, and then you'd handle however you want to do it. So if you want to just skip the error, you can just put something like pass, or just simple print saying that you caught some exception, or any other processing you may want to do. Okay, and there is an optional else block that you can put. So else block can be used to contain normal processing. So if you have some result that comes out here that has to be used afterwards, then you can additionally put else and then continue. Say we can probably move this print in here, and then it's going to behave the same way. Okay. So there was no error, then I'm going to move into else block. If there was an error, I'm going to move into except. Because if I put this print outside here and I caught the exceptions, then it doesn't know what this receipt is. So here it's going to complain that it does not know what this receipt variable is if there was an exception. So if I run this again, and here you can see the receipt has been referenced before assignment, which means this one does not have any values associated with it. Okay, so if you know that some of the resulting values needs to be used later on, then it's a good idea to put it inside an else block. Otherwise, for generic codes, then it can be not inside any of these exception blocks here. Okay, So now moving on to catching specific exceptions. So Pilot will complain that if you don't catch specific exceptions, that you can do generic exception catch. And normally you can check what error it's throwing by looking at the error messages. For example, let's not try. So we had our original print reciprocal, right? So if we do print reciprocal and pass in value, it processes fine. But if we pass in some string, this one throws an error, and you can check what exception it is. This one is a type error. So this is the type error exception that you want to catch in your exception. So except, and then you specify the type. So it's kind of like else if. Okay, so this is our next block. So type error can be called like this here. And then we can also try, for example, 0. And it tells me that this is a 0 division error. So we can also capture 0 division error here. Okay, so if I catch a type error, that means you passed in some type that is incorrect, then we can say parameter must be a number, right? So we can provide more specific debugging or error handling based on the type of errors that we get. Okay, if we try to divide it by 0, then we can say that reciprocal of 0 is undefined. So now we have more control over how we handle different types of errors. So if you do get an error, so always look for what error you get, and this is the exception that you want to handle inside the except block. Okay. And there is a hierarchy of built-in exceptions, as you can see here, and you can find it in the documentation in the link provided here. However, understanding all the exceptions is out of scope in this unit, so don't worry about it. Okay. And what happens if none of the handlers match the exceptions? Well, basically, if you, for example, remove this type error here, do I have that example? Yes, I do. So using the reciprocal 5, so run this. Oh, good. And then, oh, I should have done this. I'll run it again. So 0, 1 is a 0 division error, so I handled that correctly. But the normal one, type error 1, I don't have it, so it's going to give me an error again. So I didn't accept other type of error but the 0 division error, so it doesn't know what to do with type error. So it's going to try to see any other except blocks that handles this, otherwise it's going to throw an error. Okay. So normal processing stops when the exception is raised, and basically if an exception is not handled by the local function, what it does is it's trying to go back to where the function is called and see if this raised error can be handled by an exception handler outside. Okay, and if that fails, and at the very root program that called this function does not have any handlers for this, then this is where it's going to throw an error at us. Okay, so what it means is this error will propagate upwards from where the functions are called from, and if it can be handled, it will be handled there. Otherwise, if it goes all the way to the top, it's going to throw us an error. Okay, so you can handle errors at multi levels of where the functions gets called. Okay, but normally all error handling code is grouped in one place. So let's have a look at this example here. Okay. This one is about raising your own exception. So sometimes not only the program errors that you want to capture, but there are some conditions. For example, you want the users to be specific within the range, and if it's out of range, you want to throw your own exception to handle that, right? So you can create your own errors as well, or throw your own error. So here's an example of throwing your own error on block. And what we're going to do is if value is 0, we're going to raise a value error with an error message saying that my very own division by 0. Okay. Else, we're going to calculate the reciprocal. So if I run this for range -1, 0, and 1, say it's -1, I can calculate the reciprocal, code exception, and then it's going to show me this error message and process normal as 1. So what's happening here is that 0 has been passed into print reciprocal function. So at this point, what it does is it has raised a value error, and this message you pass in is going to be stored as a variable e. Okay, and it's going to look here if it has an exception block. So it doesn't have try and error. So what it does is, okay, this value error is not handled here. Therefore, I will go back to where this function has been called from. Okay, and this one has been called from this outside here, and it does have a try. So it's going to see its exception blocks, and here it has a value error as e. What it means is this e variable will store this error message. So what I can do is print, I caught an exception, and show me what I caught. And this error has been caught by this function here. So now let's have a look what else we can do. Say elif value equal 1, for instance, then I can raise another value error, and say that this is not value 1 is also exception. Okay, so now what's going to happen here is if value is 1, we could indeed calculate the reciprocal, but what we're saying is that this is not an invalid input for this function. So if I run this again, then reciprocal for -1 is fine, 0 is division by 0, but also 1 has been called here, and because this value error is not handled within the function, it's going to go back to where it's called from, and it sees that value error is handled outside, and it's going to display me the error message that has been returned by this exception that you raised by yourself. So here, value 1 is also exception has been printed as what exception you caught. So by raising your own exception, you don't have to only capture when the program fails, but you can also capture some, say, unusual behaviors or edge cases with this exception, and you can specify what you want to do with it in a different way. All right, so here is a brief exception quiz for you to try. Essentially what you want to do is try to understand this code and see if you can guess what might be printed with these inputs 0, 5, 1, and string 4, and then try to run it to double check. All right, so in this video I will not try this. You can try this on your own time. So the final item is about debugging. So we briefly covered about debugging, but let's cover more about proper steps of debugging. So what normally happens is when you start coding is you want to see the cases that it succeeds, but as you get more experience, you want to find out what cases will make your code fail. And obviously, this will link back to capturing exceptions and make sure you can address all different scenarios to make sure that your program runs smoothly, whichever interactions it might have with the user. Okay? So to ensure this, make sure you have some simple tests in mind even before you write the function to make sure that you can test this easily later on. Okay? So doing the thorough testing is required to make sure that debugging is quite easy to do so. And when test fails, you have to find the cause. And there's a few simple steps that you can use to find these causes. So here. Normally, we'll try to find the symptom and then try to lead that to the cause. And generally, 5 rules can be applied here. Understanding what you intend to do, replicating the failure, you want to divide and conquer to isolate where things went wrong, and deliberately changing one thing at a time and retesting, and of course documenting what you have tested, so next time you don't have to revisit the same test again. So these are the simple steps of doing the debugging, and now as you have more experience in testing and be able to handle exceptions, you can apply these concepts more easily. And to help you with the debugging process, one of the handy function of Python for automating the test is to use the doc test. So we have seen writing the doc strings in the triple quotes inside the functions, but it also has a feature that you can write some automated test here. So for example, you can specify the document, so this is the doc string, but you can also specify, okay, execute this code for this function, and then you can type in some expected output. Okay, then what's going to do is when you call a doc test with the test mode, then it's going to execute this code to see whether what you have written here is true or false. Okay, so let's have a quick look at that. Comment these guys out. Okay, so here's the doc test. Basically what we want to do is, as you can guess, this is good for testing purposes, but for product code, you don't want the doc test to be running, so we will hide it inside if name equals main, then only run. Okay, so if you run this, this is what we get. Okay, so what it's saying is that odd silly, we call this, we are expecting SLY only, but we got the full string silly. So this way you can automate some testing yourself as well. So 1 out of 2 tests also have failed. So it tells me if the test fails, it will show me these messages. If it passes, and it's going to show me nothing. So what's going on here? So this way we can go back and check whether our code is doing the same thing. For instance, I'm calculating something in my result, but unfortunately I'm returning the same string. So that's probably a problem. So I can probably fix that to say return result. Okay, let's try it again. Okay. Oh no, this time I failed both tests. Okay, so I was expecting SLY, but I have returned IL, and I was expecting M, but I gave nothing. So this way, it looks like I'm returning an alternative to the expected answer. So this probably means I'm doing some modulus wrong. So maybe if I change to 0, this is going to be fine. So this time I run it, and that has fixed this particular code. All right, so I have now passed all the tests, and therefore this code probably be working fine. You do have to note that your doc test should be correct, and even if you pass all the tests, doesn't mean your code is working as you expect, because the coverage of the test you put it into the doc test may not be complete as well. So this way, it provides you a nice automated way to check some of the test cases rather than you having to manually do so. But do note that depending on the comprehensiveness of your doc test, your function may or may not be complete or doing all the expected behavior as you anticipate. Anyway, that's it for this video. We covered in this video about exceptions, debugging, and leading to doc tests for automated testing. So hopefully you find this useful. Otherwise, I'll see you in the next video. Bye bye.